All right, this is going on page 141. We talked about sequences last week, right? Then we started talking about series yesterday. Series is the sum of those. So we had arithmetic series yesterday. And I have put all the little things up here. So here are your sequence formulas, your series formulas, and we'll talk about what convergent means here in just a minute. Okay, so all the geometric series is the sum of a geometric sequence. Okay. We have a little formula for that too, so we're not adding up an infinite amount of numbers or whatever. So to find the sum, again, we have to sum up a geometric series. We use the following formula. So this is the capital S with the n subscript again. And then it is a sub 1 times 1 minus r to the n power all over 1 minus r. Do the r's cancel out? No. Okay, if they did, why would they be there, right? So don't go doing anything weird with that. Okay, so where n is the number of terms, A1 is the first term, and it's because there's a lot of things that are the same. So the n, at least it's A1 and n are the same in all of them, right? And r is the common ratio. So it is repetitive, whatever, common ratio. Because when we did the geometric sequence, it said this exact same thing, right? Because r is the common ratio and whatnot. So just make sure we define what's what. Alrighty, so let's look at how this works here. We've got, it says find the indicated sum for each geometric series. So I want the sum of the first 9 terms, right? That means that n is equal to 9. I need the first term, which is 2. And I need the common ratio. Am I multiplying by 5 each time? Is that what's happening? Yes. So r is 5. I don't need the 9th term like I did before. Okay, I have those things. I'm going to substitute it into that formula. So the sum of the first 9 terms is 2 times 1 minus 5 to the 9th power all over 1 minus 5. I would put this in the calculator. I would use the fraction function on the calculator so that I can make sure that this is all put in the correct way. Because if you do that, you'll see the parentheses, the exponents. It'll be beautiful and obvious that you're typing it in right. So go ahead and do that. Good Lord. Did you not get yours either? You're just staring at me for. Push buttons on it. Go get your calculator. My Lord. It is a really big number, yes. But if you think about what's happening, these numbers are growing pretty quickly too, and you're adding them together, and you should get 976,562. Is that what we got? Yes. What questions do you have? All right, no questions. So let's look at the second one then. What is in here? On number 2, 8. What is A1? 72. And then I need R. R is a common ratio. I'm multiplying by what? Negative 1/2. Okay, so it's always about what you're multiplying by. Multiplying by a negative 1/2. All right, there are your pieces. So we put it in here. S of 8 equals a sub 1, which is 72, times 1 minus r, which is a negative 1/2 to the 8th power, all over 1 minus a negative 1/2. Okay. So again, I would use the fraction function, and even when you have a fraction, you can put a fraction in that calculator so it looks all nice and pretty when you're typing it in. Watch the negative signs. put the fraction. You should get 765 over 16. Okay. 765 over 16. Is that one not what you got? How'd you get that? Oh, when you do this to the 8th power, you have to have that negative in parentheses. Like down here, when you type this in, if you don't have this in parentheses, it's fine, but this has to be in parentheses. Okay? Otherwise, it changes the value there. Does that make sense? No, yeah, you can't change that negative to a positive there because of the exponent, so you'd have to do it the right way. Okay? We good? All right, questions? All right, let's jump down to number 5. So this is our summation notation, right? What is this Greek symbol called? Sigma. Good. So this is sigma. So that means I want the sum of terms 1 through 7. So what is in here? 7, because you got 1 through 7, it is 7. We need to find the first term, and we need to find r. What do we already know by just looking at this? A or r? Can we take a sub 1 or r out of this? Or both of them? Both of them, because look, this is your geometric sequence right here, right? This is the form that it's in. So we know A1. Now we could substitute something. We could substitute 1 in and get that, but A1 is 3. This is A1. And this is R, so it is -4. I don't have to actually calculate any of that part. Where with the other one I did, I had to find things. So then I substitute this in, S of 7 equals, do 3 times 1 minus, and again in parentheses, -4 to the 7th power, all over 1 minus a -4. Type that in because I want to make sure that y'all are typing this stuff in the calculator correctly. Good. 9831. Okay, and if you're not getting that and you don't know why, okay, then let me know. What questions do you have? All right, y'all do number 6 on your own. It is a big number. Yes. Good. It's okay. Yeah, and we learned fractions in 4th grade. What's your point? Like, all right, what questions do you have? Are we all okay with this? We're getting the right numbers in the calculator? Because half of this is typing it in the calculator correctly. So we're good. Okay. All right. So, Good. All right. Don't be a whole million off. All right, flip it over. Let's look at number 10. Now, number 10 doesn't go from 1 to 12, right? So what is in here then? 12 minus 5 plus 1. Good. So n is equal to 12 minus 5 plus 1. So that is going to be 8. Very good. So I need the first term, which is a sub 5, right? So instead of a1, I really need a5. That one I'm going to have to calculate because this is a1, but that's not what I want because that's not where I start. Does that make sense to you? Because I'm starting with the fifth term, not with the first term. So when I substitute this in then to find the fifth term, that's going to be 1 over 20 times a negative 5 to the 5 minus 1 power. And that's going to give me that fifth term there. Yeah, you could, but I just want to make sure you knew where everything was coming from. Should hopefully get 125 over 4. Yes. So this is 125 over 4. So there's my n, there's my a5, and then it should not be negative. Right, but hang on. Oh wait, I'm sorry, I was looking at the wrong thing here. Yeah, the exponent's even, so it should be, it's probably because you didn't put parentheses around the negative 5, whoever said that. Okay. I was looking at the wrong part of the work when I was confused there, so yeah. So it should be positive. And then we also need r. What's r? Negative 5. That we still can get from there. There's your r right there. So now that we find this, and we want the sum of 8 of the terms. The first of those terms is 125 over 4 times 1 minus that negative 5 in parentheses to the 8th power, all over 1 minus a negative 5. And again, you should be able to do a fraction and a fraction, so it makes it all look real nice and not confusing like some calculators. Yes. Well, technically, it's a really, really small number. Uh-huh. All right. What questions do you have? Let me know if you're having calculator issues. You got to speak up because I can't read your mind. I'm going to assume we're typing this in and we're getting it. But if it's not happening, you got to say something. All right. Okay, let's look at number 12. We're only going to do one application problem down here, and you're only going to have one on your assignment, so you don't need to freak out on me, right? Pretty much, yeah. Because it's the ones that I feel like is something that might actually be something that you need to know how to do, right? That you might, when you're investing money, you need to know how this stuff works. So Amari invested $12,000 in a retirement plan with an expected annual return of 7%. What is the balance in the account at the beginning of the 30th year? All right, so that means we got to figure out your A1 is what you're starting with, and that's 12,000, right? N is 30. R, now let's think about what R is though, because R is your ratio, right? The rate is 7%. However, the actual, so let's just say, what's 12,000, what's 7% of 12,000? Just go ahead and do that on the calculator. That's fine, go ahead, I want you to tell me that. I wouldn't expect you to do that. 840. So this would be, so the next year, this would be our next term, right? So this is the first term, this is the second term. Y'all agree with that? Okay, and then, yeah, then 7% of that. But we don't need to find the rest of them. I just want you to think about what the ratio is. The ratio is this term over this term. So if I take 12,840 and divide it by 12,000, do that and tell me what you get as a decimal. You got 1.07, right? Because that 7%, this is, the 840 is 7%. This is 107% of this. Does that make sense to you? So your rate is, yes, the interest rate or whatever is 7%, but the rate that we're talking about here, or the common ratio, is 1.07. Does that make sense to you? Okay, so think about that. That's how you add tax, really. Tax is 8.25%, but if you just want to find the total, you multiply by 1.0825. It gives you the total with tax and everything, right? It's just a different way to look at it. Instead of doing, huh? And you can do that. I mean, there's nothing wrong with that. You find the tax and then you add it, or you can just multiply it by 1.0825, and you don't have to do the adding step. It's the same thing either way. So, yeah. Oh wait. 825%? Oh, you mean like on the calculator? Yeah, yeah. Some calculators, the percent button, you can do plus 8.25%. Yeah, but not all calculators have that percent button. I see what you're saying now. Yeah. No, like tax on stuff. Y'all stop it. Okay, so now that we have all of this, even though it's a word problem, it's exactly like the rest of them. So the sum of the first 30 terms is, we take the first one, 12,000, times 1 minus the rate, which is 1.07 to the 30th power, all over 1 minus 1.07. Yeah. It's compounded annually on this one. No, this is not that bad. Yes, so I want you to think about that. You take $12,000, which is a lot of money, but it's not that much money, and you just let it sit in the bank account with that type of interest. You don't touch it. Yeah, I know, but guess what? When you go to retire, like you're making money along the way that you can use. That's compound interest. No. Okay, well, okay, let me put it this way. Not necessarily a bank like with a savings account. Most of the time they don't. But there are some retirement plans and investment options, like when you do stocks and different types of bonds and things. Then, yeah. Right, but there are some of them where you're not allowed to touch it for 30 years, and those usually will give you a better return because you can't take money out, and they know they're guaranteed to keep your money for that long and get the interest, so you're going to earn more interest that way the longer you wait to get it out. So, okay. What? There's like bonds, and there's all kinds of different things where there's different types of investment accounts where you can't touch them. Yeah, that's right. All right, so y'all grab the next piece of paper. Oh, I hope did yours. Let me see what did it. Oh man, I know, but this will be short. Okay, so apparently when I moved stuff, it kind of all shifted. So we're going to have to adjust something here. I'm sorry, I don't always catch that until I'm looking at it up here. I know, it's so terrible. So let's just do this. You see this S1 here? Kind of ignore it in there, right? And this bracket disappeared. And then just mark these out and we'll rewrite them. So this should be S1, S2, S3, S4, S5, and S6. Okay? So we only have 4 terms up there, right? We're going to need a total of 6. So let's go ahead and do the next 2. So if this is 2, 4, 8, this would be 1 over what? 32, and then 1 over 64. Okay. So the first term, S1, so when I just add up the first one, it's 1/2, right? Or actually, I want this as a decimal. I know that's shocking to you, but 0.5, yeah. And then I'm going to add the first two. So in your calculator, do 1/2 plus 1/4 and give me the decimal. And it is 0.75. Okay, so we have now added the first two terms. Now to the sum that you already have, add 1/8. So just do plus 1/8. And then give me the decimal. 0.875. Good, 0.875. And then just to what you have there, add 1/16. 0.9375. And then to that, add 1/32. 0.96875. And then we add 1/64 to that, and you get 0.98435. Yeah, it's infinite, and so in a way it never really gets there, but you also never really get to infinity. But do you see how it's getting closer and closer and closer to 1? So S sub n is equal to 1. So if I go to infinity, right, it's going to converge to 1. So it says a series that approaches a certain sum is called a convergent series. It converges to 1. Okay? So if it approaches a certain number, it doesn't always have to be 1. In this case it is, but it converges. It's a convergent series. Okay? Now let's look at this second one, which again we have to fix these S's that have been weird. So this would be S1, S2, S3, S4, S5, and S6. So the first one is just 0.5, right? And then 0.5 plus 1 is 1.5. Then I add 2, and it's 3.5. Then I add 4, and it's 7.5. Then I add 8, and it's 15.5. What would be the next number I add? 16. So I add 16, and I get 31.5. Okay. So do you see this approaching any number? No, if I keep adding for all the rest of the numbers for infinity, it is going to actually approach infinity, but infinity is not a number, okay? So it says a series that does not have a certain sum is called a divergent series. Infinity is not a number, so if it's going to converge to infinity, that's not converging. So it either converges to a certain number, and it's convergent, or it doesn't, and it's called divergent. And it's really easy to tell if this is going to happen or not. Here's how you tell. If the absolute value of r is less than 1, then it is convergent. And we can actually find the sum. If the absolute value of r is greater than 1, then it is divergent, and we can't. Okay? Convergent, I can actually find the infinite sum. Divergent, I cannot. So to find the sum of a convergent infinite geometric series, we use this formula. S sub n is equal to A1 times 1 over 1 minus r. It's that easy. That easy. Yeah. Just everything you've learned is a lie. Be crazy, wouldn't it? All right. So it says determine if the series is convergent or divergent. If it's convergent, then find the sum. So when I look at number 13, and what would r be here? -6, right? So multiply by -6. So r is equal to -6. If r is equal to -6, is it convergent or divergent? If it's greater than 1, it's divergent. Absolute value, dear. Okay, so it's a divergent. I can't find the infinite sum, right? Uh-huh. What do you mean, what is pi? Well, pi is a number, it's not a series. Does that make sense? Pi is just a number, it's not a series of numbers. Okay. All right, so then now let's look at this one. What is R here? So R is 1/3, right? Because I'd be multiplying each one of these by 1/3. So it is convergent. So since it is convergent, I can actually find the sum. S sub n is equal to, I take the first term, which is 72, and I multiply it by 1 over 1 minus R, which is 1/3. And then you can put that in your calculator just like it looks. I would use the fraction things there, way easier than parentheses and everything else you got to do. But make sure you have parentheses where those parentheses are. That's important. $24? Nope. Okay. No, you didn't do anything wrong. I'm just using somebody else's work, and that's a mistake. Okay, 108. I trust that that's right. No, did you get 24? Oh. You want me to make sure? Okay. No, I'll do it. I looked at what he wrote in. I looked at what he typed in, because we typed it in right. We did the first term. That's all right. Yeah, that's correct. Okay, I'll double check, though. Hector's panicking, so I don't want him to panic. Yeah, it's 108. I don't know, because I didn't actually work it out. I was using somebody else's work, because I worked some of these out, but I didn't get to this page. So I know this is why you don't copy from people. Exactly. This is what happens when you copy somebody else's work. Okay, let's see. Oh, my goodness. These have jumped all over the place, too. So let's do, no, well, we're not going to do that one. I don't know what the heck's going on here. We can just do these two. Let's look at 17. The numbers aren't even right. What the heck is going on here? Okay, whatever. Let's look at this one. What is R? Three-fourths, right? Wait, this is R right here. So it's just 3/4. So is it convergent or divergent? Convergent. Yes. So then S of n is equal to, what's A1? 224. It's right here. So 224 times 1 over 1 minus 3/4. And I will type this one in just to make sure that everything's good here. Yeah, if it's 24, I'm going to laugh. No. I got 896. Is that what you got? Yes. Okay. All right. Then I want you to do number 18 while I hand out the assignment. You can do it. 18. I would put it, since you have to start with decimals, usually you would end with decimals. It's just kind of the way it works. But it wouldn't be wrong, I guess. The calculator is probably going to give you a fraction. So. You can put the decimal, yeah. Okay, so let me type that one in again to make sure my answer is right. Now I'm second guessing everything. 1 divided by minus a negative 0.2. Okay, so I got 75 over 2 or 37.5. All right, are we good? All right, so grab the assignment so you make sure you know which ones you're doing, because I'm not going to make you do every single one of these because they get very, very repetitive. You are going to do 1 through 19, just the odds. 1 through 19, the odds. Yes, just the odds. And I only had you one application problem. You're going to have to find R, but I think you can handle it. It's just like you find R in all the rest of them. So.